Hello and welcome to this poster. My name is Augustin Bussy and I work at the University of Zurich together with Frederic Stein and Jörg Hutter. And we all work on the CP2K software package, which is an Ab-Initio molecular dynamics program. Recently, we've worked to go towards exascale computing, and we are leveraging here the work of a colleague of ours that work on GPU optimization of low-level operation, such as dense matrix multiplication or sparse tensor contractions. We are quantum chemists, so we work on a higher level of theory. For example, here in a double hybrid functionals, the idea is to mix exchange and correlation from DFT and wave function theory to get the best of both worlds. In this case, we are using MP2, and MP2 has a lot of dense matrix multiplications and numerical integrals, which are perfect for GPU acceleration. So in our case here, we've been able to do calculation that use around 75% of the GPU at best, which is quite good. One of the biggest issue with MP2 is that we need a Hartree-Fock ground state. In this Hartree-Fock calculation relies on these four-center two-electrons integrals, and these are evaluated analytically on the CPU, so there is no GPU acceleration. And one way to circumvent that is to use the RI approximation, so we go from four-center to three and two-center integrals, and now the computational loads goes from integral evaluation to tensor contractions. And tensor contractions are GPU accelerated. So that allows us to get some GPU performance also in Hartree-Fock. We also exploit sparsity in those tensors, and that allows us to have a very nicely scaling method. In this case, we have a quadratic scaling here, which is much better than the formal n⁴ scaling of Hartree-Fock. So it also allows us to go to very large systems. Now, just a brief word on our low scaling Laplace SOSMP2 method, which is also relying on sparse tensor contractions and also scales quadratically, which is very good compared to normal MP2, which is n⁵. So in the end, all those development allows us to have very high quality quantum chemistry methods that are ready for the newest generation of supercomputers via GPU acceleration and good overall scaling. Thank you for your attention.